Today's networks are changing fast, and employees, devices, and infrastructures are more distributed than ever. Gigamon Threat Insight is a cloud-native, high-velocity network detection and response solution that's purpose-built to enable you to get in front of this transformation. Learn more at securityweekly.com/Gigamon. Do you worry about ransomware, data breaches, reputation damage, especially from phishing attacks, on employees working from home? The facts are, top cloud security tools have a 15% failure rate. 51% of phishing is social media based. Pixum knows because Pixum detects and stops breaches at point of click. Pixum's AI real-time solution detects actual fraud happening in a browser and stops it. Know your real security gaps. Get a phishing actualization test free at securityweekly.com/Pixum. That's PIXM. Welcome back, everyone, to Enterprise Security Weekly. If you missed Security Weekly Unlocked, you can access all of the great content on demand, whether you've registered before the live event or not, by visiting securityweekly.com/unlocked. Click the button to register or the button to log in. For this segment, we are joined by Amit, Malik, and Ganesh from Uptycs for a discussion on evaluating the MITRE ATT&CK evaluations. Which is not the first evaluation of the MITRE from MITRE based on the MITRE ATT&CK framework. But Ganesh and Malik, welcome.
Paul, great to be here. Thank you.
Yes. Ganesh, I know you've been on the show before. Amit is the principal researcher at Uptycs, responsible for the research team specializing in threat detection, threat intelligence, and security architecture. So it's good to have you on the show, Amit.
Thank you, Paul. It's good to have you.
And today, of course, we're going to talk about the wonderful MITRE ATT&CK framework, but also the some of the evaluations that they have published in the past, and one that I think they're getting ready to publish. I'll turn it over to Ganesh and Amit to talk about. Give us a little history, I guess, on the MITRE evaluations.
Yeah, so for us, we came across MITRE, I'd say almost a few years ago. And as a venture, as our product evolved, we've been paying attention to them because we wanted a third party to evaluate our technology so that potential buyers or those who want to get a better appreciation for how we do detection and response might be able to quantifiably measure us. What we liked is, unlike other qualitative approaches to saying one approach might be better versus other, we felt that them being a government entity and potentially a neutral entity, having a good appreciation for various malactors, their techniques and tactics, and them coming up with the framework to say that here is a bunch of evaluation criterias, and us having the opportunity to be one among the 30 vendors globally to participate in that, we felt really good on a couple of different fronts. It allowed us, of course, to have our product be prepared. But more importantly, we had an approach which we thought might align with the way they do the evaluations, and we are happy to share some of our understanding. Of course, as is the case, the evaluations themselves are going to be out later in the year, but we are happy to share our perspective on the evaluations and why we feel they are important for the community at large. Hopefully that makes sense.
Yeah. And so what MITRE does is take some malware, and the type of malware is, the particular malware has changed in these evaluations. And then they used vendor products and see how they're able to detect the various stages of not just the malware, but particular campaigns, right? So it even extends beyond the malware, correct?
Yeah. So what they did so that it's something which is universal and quantifiable well in advance based on the spectrum of various malware and threat actors out there. They give you advance notice, and this year very specifically it was Carbonac and Fin7. These are two representative samples that they give you a heads up in terms of how might you prepare should they do the detonation of the malware and use your technology to observe how much you can detect and how much context you can provide for a response and the likes. And that's to your point, that's exactly what they do. And then they put you to the paces and they see how well you fare when they do the actual work.
And this is not just it's not just endpoint, right? I mean, you're collecting telemetry from servers, endpoints, Windows, Linux, right? It's not just testing the efficacy of something detecting Windows events, correct?
No, you're absolutely right. One of the things which we really appreciate about MITRE's charter is that they are trying to come up with a standard which extends beyond where traditionally a lot of sensitive malware was in the realm of Windows, and they've extended it to quite a bit to go beyond to Mac OS and Linux this year. And based on what we can see, they are extending it to cloud security as well as containers. And we've been quite a big fan of this approach because the detections that we provide also span the same attack surfaces or attack vectors that MITRE is going after. But to your point, yeah, it's expanded quite a bit beyond. In the past, the focus used to be quite Windows-centric. The evaluations that we were subjected to involved a fair bit of Linux as well. And then if you look at their standards these days, they provide extensive coverage on detections and what one could be doing for Mac OS as well. And it's extending to containers soon.
That's really cool. What were some of the different phases of the attack, and how did you, kind of configure and apply a certain methodology to detecting the various phases of an attack?
Yeah, I'll set the stage for my colleague Amit to give you a deeper dive on this. But to give you an idea what is typically involved, at least at high level, and all of this information is on the MITRE website. But given that we were given advance notice, our preparation in anticipation of this went something like this, and we can give you a demo using a similar malware for you to get an understanding. By deploying our technology on the hosts, which are going to be the subject of exploitation, we had an agent or a sensor which was in a good position to capture telemetry. And what we do then is we capture the telemetry, send it to a location in the cloud, where there is an act of using our threat research team, which takes the potential logic that MITRE ATTCK framework provides as an example, and then says, how do you map this logic into detection as code? And in doing so, what you're effectively doing is, if you take the stages of attack as defined by MITRE, it's neatly categorized into a two-dimensional matrix. One dimension of the matrix as you progress from left to right as a function of the column headers is the various stages of the attack. And then if you say that each stage has a kind of a set of techniques and what tactics people might use given that stage, then there is a sub-tactic mapping. And our approach was to plan in advance and do the necessary research, especially Amit and his team have been following it quite a bit. And, he'd be happy to take it from here to give you some perspective of how we apply detection of logic to detection as code, primarily to translate MITRE ATTCK recommendations for saying, here are some detections that you might encounter when malactors execute a certain type of code or they execute a certain sequence of things. How do you take those signals of detections and then do correlation is what we did. And Amit, this might be a good point for you to step in and perhaps outline our approach and share more. But Paul, I'll pause here for a second. Hopefully that sets the stage. I just wanted to share as to how we saw what MITRE recommended and how we actioned it.
Yeah, I think, I like your approach because it takes I don't want to say simpler because it's maybe not the right word, but a more pragmatic approach of just understanding what the events are and allowing the analyst that I would do years ago manually to go, well, that event by itself it could be bad. It looks bad, but it's only bad if these other things happen, right? you're
Yes.
providing that information to the analyst, whereas a bunch of a manual process in the past before tools like this.
Yeah, because there's a lot of precedent today in terms of, if you will, stream-based computing, which allows you to like kind of contextualize billions of events by doing correlation and narrowing it down to like signals, and then correlating signals to say their detections. I don't want to steal Amit's thunder. I think he's put some work to like illustrate how we accomplish this. Amit, would you be able to like share that perspective and outline what our approach has been here?
Yeah. Thank you, Ganesh. Yeah, sure. So, let me share my screen because it's much better to show it visually. Okay. I hope my screen is visible. So as Ganesh said, right, so we collect, lots of telemetry from the endpoints that includes multi-platform, Linux, Windows, Mac, containers, and cloud workloads. And that's basically, billion type of events that we are getting into our data lake. Now, this much telemetry is coming to us. Now, how do we identify that something is suspicious or malicious inside this massive amount of the telemetry, right? So our threat research team basically works on identifying, latest and tracking the latest threats as well as the open source intelligence that we get. And we have actually built, some sort of suspicious indicators that once this telemetry flows into our pipeline, then we apply these suspicious, the rules, you can call it. And then these rules actually create, separate out whatever the suspicious things are there into this telemetry. Now, what I'm showing you here is just one example of that rule that we actually look into the telemetry. Now, if you look at it, what we are looking at is a very simple thing. We are just saying it's WMIC execution detected for lateral movement. Now, since this telemetry is coming from the endpoint and we are actually, looking at the suspicious signals, so we have carefully, categorized these indicators into different MITRE ATT&CK buckets that they have created, right? Because this will allow us to track the propagation of attack from initial point to the last point inside the MITRE framework, right? And if you look at it, it might look like a very simple logic right now because we are just looking at the WMIC and then bunch of CMD line options in that. But this is a good indicator to look at as this telemetry is coming to us, to look at, okay, this might be suspicious. Now, when we are looking at this problem, at this point, we might, we can say that, this is suspicious. It's not really a malicious one because this type of activity could be from a benign activity as well. So at this point in time, we cannot really declare this as malicious.
Yeah, I mean, I like that because I think as analysts, we've all been there, right? We see an event, and I think you've got it scored at like a 5, right? And you're like, by itself, like, yeah, it's a 5. Like, it's not the end of the world, but it depends on the context, right?
Yeah, exactly. Now we have given the score it to 5, but we have also the some of the the rules where the score is very low, like we're pretty 0.5 to 0.3 to 3 to 2.5, and in different buckets of that. But here we have two problems basically that we are facing. The one problem is that if we increase this logic to very specific to a malware, then we basically lose what other segment of malwares can do or other segment of threat actors can do. Now, it might not be really specific to the malware. It can be, the malware is basically executing some command that is not part of the malware, but the part of the methodology of the attacker, the goal that the attacker is trying to achieve, right? And if we basically create this rule as very benign, in case if we just hit on the WMIC.exe, then it might create a significant amount of volume that the analyst cannot really handle that thing, right? So we have to actually create a balance in that. And since this telemetry is flowing in our pipeline, we have something we call as a rule engine. The telemetry flows through that rule engine, and then rule engine basically collect all of these suspicious things that comes to us. And then the second component that actually works is basically the correlation engine, or Ganesh like to call it as a lambda analytics, but for the simplified way, we can say it, let's say it's a correlation engine. Now, this correlation engine look at these suspicious indicators and then try to identify, okay, how many things are happening at this point in time, right? And if there is a surge in suspicious signals during that time frame, then it basically creates and prioritizes that detections, saying that, hey, this is something, something serious is going on here, right? And this basically solves two purposes. And this is our first-hand experience, actually, in these problems, that we can actually provide continuous threat hunting as well as threat detections with the prioritization of the signals as it comes to us, right? So this is one structure where we have lots of telemetry, including with the event. We fetch lots of information from that, like integrity level, whether it's a container process or not. Our host query provides lots of deep level information around it. So this is one example. Now, I have simulated some of the attack based on our experience, and they actually relate with what the attackers do in the real life. So I just like to show that how really it looks like in the field, right? Now this detection, as you see, as we have basically correlated the 42 signals, and this is a combination of malicious activity happened during that that incident or that activity during the time frame, right? And what we have here is the score that basically prioritizes the detection. It says that if it's 10 by 10, that it means something is really bad is happening there, and we need to look at it immediately, right? And then we have this ATT and CK metrics that basically light up all of these techniques and sub-techniques or the tactics that we have in MITRE. And it basically provides an quick overview of how the attack is progressing from different segments of the MITRE.
Yeah, right? And I really like this, and I know for our audio listeners, you may want to check out the video because it is very much a visual. But essentially, you've taken 42 signals and visually mapped them to the MITRE ATT&CK matrix and said, all these individually, sure, they've got some level of risk or severity, but these 42 signals together chained in this specific way, exhibiting this behavior, means there's an attack. And, again, this has largely been a manual process, back in the day when I was doing this level of analysis. To have it, rolled up into this particular view, I think is really powerful.
Paul, to your point, one thing which you get is even if it is not a big detection where you're going to start running all over the place, it gives you a sense of the density of the attack because the visual presents something saying how many things have lit up in the matrix, perhaps it is noteworthy nominally, right?
Right.
So at least it surfaces that thing to give you the context to say, let me explore or let me just sit for a little bit longer.
Yeah, and also underscores the importance of process level visibility. What is each process doing and what events are each process generating, and using that data to develop whether there's an attack going on or not, I think is a big differentiator and a huge tactic that defenders need to have today, capability.
Yeah. So what we have here is basically the signals comprise two components. One is the alert and another one we call as event. Basically, when the event are coming, our rule engine is labeling those events into different MITRE techniques. But the correlation engine only work, and consider events into the malicious to calculate the malicious score when there is an alert, when there is some significant activity, right, that we consider as suspicious. In this case, we know that basically in this particular incident, we have 14 alerts that got fired. And we can look at, we have information like, if the Microsoft Office is loading the VDL to execute the macro. Now, standalone, this alert might not be really significant, but as I said, we have done this correlation and these signals are coming and the score is, pretty high in this case. If you look at the events, then events are not really that created or something significant, but they are contributing into the detections as the correlation engine calculating all of these things, what really happened during that time frame, right? Now this is the textual information that is available there, and analysts can pretty much understand what exactly is going on here. But in order to understand it much better, what we have done is basically we have provided a process graph as well that provides the initial, the stage of the attack to the next stage the attack is going to, right? And here, if you look at it, we have pretty much from the very beginning, the starting of the very beginning process that is actually responsible, the childs of it are responsible into the malicious activity. Now, if you look at it, we can see that it was the Windows WinWord process that actually created this problem. And I'm not sure if we can see this, but these are the command line options that are saying that there is some COVID-related participation guide template.docx or docm, something like this. This file opened into the doc. Now, this is a normal mechanism that the attacker sends the suspicious or the spear-phishing the emails to the victims, and then victim basically open these things. Now, COVID is like kind of hot topic right now, so attacker might basically choose this topic to infect the users, right? But in the background, what really happened to user, it will look like that this is some document related to the COVID and some information related to the COVID. But in the back end, the document actually did open the PowerShell, and then PowerShell actually opened the MSHTA, right? And then MSHTA again opened the PowerShell to download, as we can see in the CMD line options, that it's downloading some rat.exe from the internet. And at this point, we can see that the PowerShell also launched the schedule task to create a cron type of job into the Windows. In Windows, we call it schedule task, basically. Yeah, and we can see that CMD is also creating a rag.exe, calling the rag.exe, and this rag.exe is creating for persistence into a registry key into the registries, right, for persistence. And we have all of this information actually mapped into the MITRE ATTCK metrics as the attack progressed, right? We have some element now in this profile. I choose the aggressive one. We have a lot of information here. If you look at the sockets, then it can display the sockets that it's trying to connect to. Now, in this case, since we simulated this attack, so this rat.exe is actually connecting back to our controller, which is listening on port 444. Right?
Yeah, it answers so many of those questions of, okay, well, a user is going to get an attachment, they're going to open up with Word, and that's normal behavior. But it's all the things that are happening in the background that you're highlighting for the analyst of, like, why did it spawn a PowerShell instance? Why did that PowerShell instance then connect off the internet to some host on this port? And you're getting visibility into that.
Yeah. And we also see, like, a great level of details, like certutil got launched and it created some file, red.exe, and then it's got launched, right? So now, if you look at this time frame, this is 823, and the incident is actually from this time frame window. Now, normally what really happens is, like, once attacker compromise your machine, it's very it's not very common that they get what they are interested into, right? So normally they get one system and then they have to move laterally to other systems, right? For the attack, to complete their goal, right? So what really I have, this is a second detection. Now I'm showing you, and this is the activity. You can assume that activity done by once they took the control at this point of this machine. And in this case, we can see that this detection is coming at 9:27, which is like, roughly an hour later, what the activity that we saw on that machine, right? And here also we see that the correlation has actually calculated the score as 10 by 10, and we see, like, lots of activity into the MITRE matrix as the attack is going, from one stage to another stage. Now here, if we look at it, we see some serious alerts that, like WMIC is for lateral movement. So we can assume that there is some sort of lateral movement activity is happening in this detection. Now, if we jump, we can actually jump onto process graph, and we can see.
Oops.
Just give me a sec.
Demo effect.
Yeah, it happens sometimes.
It looked like, yeah, you just your session time. You had all the tabs queued up, and then your session timed out.
Yeah, looks like.
No worries.
Yeah, okay, we are back on the stage. Yeah. So the process graph that we have here, as you can see now, this activity is happening in an hour, right? But if you look at it at this context, we have the entire context of this from the very beginning of like which processes are actually involved in it, right? And we can see here that the WinWord actually knows the PowerShell, then the MSSTA PowerShell, and the Red.exe. That were basically we saw into the previous detections that were, we saw in that, right? And now, at this point in time, what attackers are doing is basically this Red.exe is a remote administration tool, so they can take the control of the system out of it, and then they are using basically CMD and then launching some commands in it to identify like NL test. They use this command to identify the domain controller on the network, and they also use the who am I to basically identify who is the user, the current access they have on this system, right? And they use the net.exe as well to basically look into the shared drives and the user on the system. And then what they basically did is let me see, I can't see this. All right, this window is
If I could interrupt and ask a question real quick, Amit.
Yeah.
So this is basically all the stuff you're showing us. This is the stuff that when they do the evaluations, they're looking to see that you caught these different actions, right?
Yeah, that's true. So as you can see, this is not just malware specific, right? So the malware just ended at red.exe, but now the attacker has control of the system, and then attacker is now actually creating, looking at launching these inbuilt utility of the machine, right? And they don't really have to create any other binary on it. They are just using the inbuilt utility of the system to collect this information and then execute the commands, right? And this is pretty powerful because from a detection point of view, it's kind of challenge, like how do you differentiate a benign activity into a malicious activity, right?
Yeah, Paul and Adrian, to your point, if you look in both cases, Amit was illustrating the original question from Paul. You can go left to right on the matrix, and you'll see that the stages of the attack are there. The attack might thread to different boxes, but you always see between the two different machines a series of boxes lit up on the columns, but the columns always go from left to right. So you know that based on MITRE's ATTK recommendations, if there were attacks underway, the malactors are usually going to use a certain set of techniques. So the nice thing about the MITRE ATTCK framework is it allows you to map what is a generic set of techniques across different set of attacks. And that's what allows people to get comfort that there's a quantifiable way to say that, okay, what are the sub techniques and how can we collect all of them and map it and say, what's the density of the matrix telling us relative to is something that's going on right now bad or not?
Well, and you can map these against actors as well, right? Because certain actors are known for doing certain things, right?
You're absolutely right, because you bring up an important point, because now into this, if you can introduce another third depth dimension, which is, the 100-odd various malicious known attacks out there, and you can do a three-dimensional walk to say that, yes, given each type of attack, as they're going left to right, how many boxes would have been lit and what are the common techniques? And yes, you can certainly make it from a 2-dimension to a 3-dimensional cube, if you will, to do that analysis, exactly like you said.
Awesome.
Yeah. So as I was saying that the attacker did some of the activity here, but we see some of the column like lateral movement here. We see the one activity, and if you look at the sockets, then we see that there is some activity being done on this IP address that is basically the attacker controller. And if you click on this lateral movement, then we will basically get the name of the system that it's propagating from this system to the next system that the attack is going, right? Now, on this, as you can see, that this is the PC1 that the attacker is doing activity on, and from this, WMIC is actually responsible for creating other services on the remote system, so that attacker can gain the control on the domain controller, right? And this is very dense or granular information, I would say, because now here we are projecting that this particular process is actually responsible for the lateral movement, right? And we have, successfully correlated that information into our process graph. And this also increases the weightage on this detection, because it's not very common that you will find the lateral movement with every detection. It's always a high severity attack where the attack is going from one system to another system. It's not the normal commodity malwares. It's just, in fact, single machines. They don't really move laterally into the network, right? It's always the sophisticated adversary that actually propagates inside the network, right? And this lateral movement check or the correlation actually significantly enhances the prioritization for this detection. Now, what I have is basically the third detections that we are looking at on the domain controller. Now, as you can see, that this system is a domain controller, and again, the correlation engine actually created this as 10 by 10, right? And we see that the MITRE matrix is again light up with lots of different techniques that are associated with this detection, and we have around 60 signals correlated in this detection. Here, what really happened from the process graph, we know that the WMI was actually responsible on the system 1 to create the process on this system 2. So it will always be like WMI service that will create the process. And in this case, we can correctly see that the red.exe is actually the process was created by WMI. And then the attacker basically launched the cmd.exe, and then they launched the PowerShell, they launched the whoami, and then the net.exe to identify the users, and they also downloaded the mimikatz. So now mimikatz is a popular tool to extract the passwords from the system, or the anti-LM hash from the system. And they also executed a bunch of different queries or different commands to extract the information from the domain controller. Now, once the attacker normally has access to the domain controller, they can pretty much do anything, because now they have control to all of the systems and all of the users and accounts that the organization has. So it's kind of like the gold that they have, and then they can use pretty much anything on the in your network once they have access to the domain controller. Yeah, so these are like 3 things that we wanted to show, and how we actually correlate and track that into in our platform.
I like it. Tyler, questions? I'm curious to get your feedback. Sorry for putting you on the spot too.
I mean, it's all good. I think at the end of the day, for me, bridging the gap to the MITRE framework is not an easy thing to do, and the ability to kind of get at all of those data points in a way that's consumable by the end user is super, super important. And it's they always say, eating the steak is one thing, but having a little bit of sizzle on that steak makes it all the more yummier. And I think you guys did a good job of both having steak and some sizzle together on this.
Thank you.
And what I appreciated too is the attack chains can be mixed platforms, that this similar telemetry can also come from Linux systems as well.
Yes. So Amit can give you a flavor of this. For us, one of the things we do is we leverage instrumentation from different sources, but for operating system runtimes, we use an agent called as OS query. What it does is it abstracts away the system call, whether it is Linux or Windows, and tells us that if a process has been launched, here it's been launched, it's its hash, how many milliseconds it took. If it opens a bunch of files, it tells us which files have been opened. And all of that activity is coming to us in a normalized manner. So the benefit that we've had is due to like normalized telemetry being used as a basis to then map it into a detection logic to surface it as a part of a matrix for Windows, Mac, or Linux. The effort has been roughly the same because we have same data, and when someone tries to do something malicious, usually you see that there is a consistent pattern that they have to use to like break into something.
That's awesome.
Right? That's
when the results of the MITRE evaluation are not out yet, but we can expect those in likely the next month or two, or sometime in the near future, correct?
Yeah. I think that the general timeline which was put out on the website by the MITRE team is that all the evaluation results will be formalized, tabulated, and presented sometime in the April timeframe is what they have said.
Outstanding. Ganesh and Amit, I think it's great stuff. I really like the walkthrough and the visibility into these attacks and the correlation with the MITRE attack matrix is great. We'll look forward to both resources from yourselves and the folks at MITRE for this evaluation. Thank you again for appearing on the show today. For folks that want to learn more about Uptycs, please visit securityweekly.com/Uptycs. Thanks again, guys.
Thank you.